Hello everyone, welcome to our Ashram. Today, in the solution series of UPSC Mathematics Optional 2020, we are beginning with the questions of complex analysis, and this is your question number 1d, which was asked in compulsory part. Okay, so it's asked us to evaluate the integral that is z square plus 3z dz counterclockwise from 0, 0 to 0, 2 along the curve C, where C is the circle. Now this is your contour or line integration, as you can see, and it's important that we solve this question in no time, and also important factor is that we get our answer right. So I will just begin with this very simple approach, that is I'm given modulus of z is equal to 2. So I will go with the Euler form, that is I will take z is equal to 2 e to the power 2 I theta, and in this method we will get our answer in very little time. So that is why I will recommend this method to go for. Okay, so mod z is 2, so z is 2 e to the power I theta. You take the mod of this is your 2 itself. So we'll put the values. This is your z can be put as 2 e to the power I theta, that is z square is your 4 e to the power 2 I theta, plus 3 into 2 is your 6 e to the power I theta. Okay, and dz can be written as 2I e to the power I theta d theta. So we can write this as 2I e to the power I theta d theta. Okay, so along this curve, this is your 8 e to the power 3I theta plus 12 e to the power 2I theta, and I take the I outside. Okay, now it's important that we find out this. It's giving along certain path, that is your, this is your 2 comma 0 and this is your 0 comma 2. So we are supposed to find counterclockwise, that is against the clock, so in this direction. So this is, if you put it on the Argand plane, so it is very much visible that where does our theta runs from. So if we just put, if z can be written as your, if you took the initial point, that is 2 0, then z we can write as 2 comma I theta, or this can be written as 2 cos theta plus I sin theta. So cos theta is equal to 1 and sin theta is equal to 0. So it is only possible when theta is your 0. So our initial value of theta is 0. That's what I have got. Okay. So on the similar lines, we can see, and it's also seen that it's 90 degree, that what has been swept. So we can write this as 2I theta is equal to 2 again cos theta plus I sin theta. Okay, so we can find the value as well for this part, that is your cos theta is 0 and sin theta is 1, and this is when theta is equal to pi by 2. So it's apparent from the figure as well, and we have computed it separately. So I get this integral as I times, so theta runs from 0 to pi by 2, 8 e to the power 3I theta plus 12 e to the power 2I theta d theta. Now we can integrate this. So once we integrate, this is I times 8 e to the power 3I theta by 3I plus 12 e to the power 2I theta by 2I, and theta runs from 0 to pi by 2. So we can write this as 8 by 3 e to the power 3I pi by 2 minus 1 plus 6 e to the power I pi minus 1. Now this gives us 8 by 3. You can write this as cos 3 pi by 2 plus I sin 3 pi by 2 minus 1 plus 6. This is your cos pi plus I sin pi minus 1. So cos 90 is 0, so is your cos 3 pi by 2. So this is 0 and this is your sine 3 pi by 2. So this value, if you see, this is in the third quadrant, so this is negative. All sine is here, is theta is positive, so it is here, so that means it's negative. So this is your minus I minus 1 plus 6 cos pi is minus 1 minus 1. Okay. So this is nothing but minus 8 by 3i minus of 8 by 3 minus 12. So this, if we can find out, this is minus 8, this is minus 36 by 3. So this is nothing but minus 44 by 3 minus 8 by 3i. So this is the value of your line integral. Now it is important that we got this answer, but if you try to do it like the contour integration as alternative approach, which is little time consuming, but still it is also there. Now we did in the polar form. Now if you just think of doing it in Cartesian form, so modulus of z is 2, z is x plus iy, and it is giving along this path. Okay, that is your circle 2 0 0 2. So we are interested in this path. So what we can do, we can write the equation of this line y minus 2 upon x minus 0. This is equal to 0 minus 2, okay, and 2. So this is nothing but minus 1. So I can write minus y minus 2 is equal to minus x. This is nothing but y is equal to 2 minus x. Okay. So if I take dy, this is your minus dx. Okay. Now I'll put all those values and my x runs from 2 to 0 as it is apparent. So z square is nothing but x plus iy whole square plus 3 x plus iy. This is your 3z. Okay. And dz can be written as dx plus I dy, and dy is your nothing but minus dx, and x runs from 2 to 0 as it is evident, and it is running counterclockwise. Okay, so in both the things we are essentially doing the same thing, but it is in different format. So if I can write this as, I can take 1 minus I outside from this part. So this is nothing but, and x runs from 2 to 0. So this is x square minus y square plus 3x plus, if I take I common, so this is your 2xy plus 3y and dx. Now we know that y is equal to 2 minus x. So I'll put it, this is x square minus, so if I take the y square, this is nothing but 4 plus x square minus 4x plus 3x. Okay, plus I. So this is 2x and 2 minus x plus 3, 2 minus x, and dx as a whole if we want to take it. Now this is 1 minus I, and x range from 0 to 2 to 0. So x square get cancelled. What we get is minus 4 plus 4x plus 3x plus I can be written as 4x minus 2x square plus 6 minus 3x dx. This is 1 minus I and x runs to 2 to 0. So 7x minus 4 plus I, this is 4x x minus 2x square plus 6. Now we can integrate this. I minus 1 minus I. This can be written as 7x square by 2 minus 4x, okay, plus I, x square by 2 minus 2x cube by 3 plus 6x, and this runs from 2 to 0. So 7 by 2. 0 minus 4. So this is your minus 4 I can write. So this is plus in 4 into 2 plus I. This become minus of 4 by 2. So this is 2. This become plus 2 by 8. 2 by 3 into 8 minus of 12. Now 1 minus I minus 14 plus 8 plus I minus 14 plus 16 by 3. So this is nothing but 1 minus I. This is minus 6 plus I 3 minus 42 plus 16. Okay. This is 1 minus I minus 6, and if we can write this is I times 3. So this is your 6 and 26. We can write this as. So this is nothing but minus 6 plus 6I minus 26 by 3I plus 26 by 3 I square. So this is effectively 6 plus 26 by 6 plus I 6 minus. So 18 plus 26, and this is 18 minus 26 by. So this effectively we get as 3, 4 minus 40, 4 by 3, and this is your 6 and 1, 8, 2, 8. So in both the cases we saw the answer is the same. The only difference is in the first step, in the first method, what we were doing by using Euler's. First we did by Euler substitution, or we wrote in polar form, r theta format, and here we were writing in Cartesian form or complex plane or Argand plane. We were writing it as x plus iy. The key takeaway from both these methods is that it is apparent in such line integrals Euler substitution will work out, and first method will reduce time and space. Second method, if it strikes, can be used for answer verification. So that was the whole purpose of doing this question by both method. So if you decide to do 5 questions, and with calm and patience if you do, and you will have ample time to re-verify your answer. And it is often observed that in easy questions people make calculation mistakes. So the whole purpose of doing this question by 2 method was that you should be patient in the examination hall and never overlook the simpler questions and do them with earnestness and all the concentration. So if you like this video, please like, share and subscribe, and write in the comment section as to which method you solved in the examination, and you can put your timer on and check for yourself, which will be less time consuming as it is apparent. So it doesn't matter which method you do, but the whole purpose of doing this question by 2 method was just to bring to your notice that which method is less time consuming, and second point is your answer verification technique. Okay, thank you everyone for watching.